Hey, good morning, everybody. This is Don Gulling, CEO of Verteks Consulting. We appreciate you joining. Looking forward to the content today presented by Terry Henry. Terry is a longtime friend of ours and a consulting engineer at Ruckus Networks. He's been involved in the IT industry for quite a long time. I don't think he wants to reveal his age, but he's been with Ruckus, formerly Brocade, since 2001, so a 23-year stint where he's at in the infrastructure business. As we all know, wireless communications are increasingly more important. I was in an unrelated part. I was talking to a buddy who's at a hotel conference who said that people are far more likely to call for assistance if the Wi-Fi is down versus them not having hot water in the hotel. So the critical nature of Wi-Fi is known by all of us, and we're seeing an increasing density of Wi-Fi appliances as well. If you look out in the field and whatever deployment you're in, you're going to see Wi-Fi thermostats, Wi-Fi cameras, Wi-Fi, every kind of device under the sun. People have phones, notebooks, tablets. They might have three themselves, Wi-Fi phones even. So just a ton of proliferation of devices, of IoT devices, and ever more increasing needs for faster and faster speeds for all kinds of reasons. As people move to the cloud for various applications, cloud apps are getting more and more hungry for bandwidth. We saw a project just the other day where a person was moving to SharePoint online and they didn't want to do any local caching. They wanted it all in the cloud, and they're downloading, all the time. They're downloading 100 meg, 200 meg files from the cloud onto a Wi-Fi device. And the expectation is that it's going to be like it's local. So in that environment, we need to have fast, secure, reliable Wi-Fi. And as you know, these standards keep advancing. So today what we're talking about really is Wi-Fi 7 and the Wi-Fi 7 standard, which includes things like extremely high throughput and so on. So that said, it's my pleasure to introduce Terry Henry to talk about Wi-Fi 7 and AI. Terry, the floor is yours.
Awesome. Thanks, Don. Yep. Morning, everybody. So as Don said, we're talking about Wi-Fi 7 and AI and how that's going to assist you. So Wi-Fi 7 is a real thing. We've been shipping since December. We now have an outdoor Wi-Fi 7 AP, so the first one on the market. So it's real. So let's talk about why you need it, how it's going to help you, and then how AI fits into our pieces. So first, how we got here. So we went through 802.11 A, B, G, N, AC. So they were high throughput, very high throughput. And, that's to get the first 10 billion devices on board, right? And these are days where Wi-Fi was a nice to have. Most people had their PC plugged into a wire, or they brought their laptop in and plugged it into an Ethernet. And you may have had an iPad or you may have had various Wi-Fi devices, but they were sort of just a novelty and not your mission critical. And so after that, we got 802.11ax or Wi-Fi 6 and 6E, which was high efficiency. And so this was the beginning of getting that next 20 billion devices on. So now Wi-Fi is the standard, right? When's the last time you actually plugged an Ethernet cable into your laptop or any device you have? It's almost all done by Wi-Fi now. And so Wi-Fi 6 and 6E, which by far is the most common deployed Wi-Fi right now, it is about high efficiency. So it's about utilizing that airtime efficiently and getting the most number of devices on your Wi-Fi channels as possible, right? And then we get to Wi-Fi 7, which is 802.11be, although we're not so much using the 802.11 names anymore. We're mostly sticking to the generation numbers. It's extremely high throughput. So we have the efficiency that we got in 6 and 6E, but the 7 gives us some unbelievably fast speeds, and we'll see some evidence of that in a minute. So Wi-Fi 7, and this applies to all vendors, right? So if you're not a Ruckus Wireless customer, it still applies to all vendors as they roll out their Wi-Fi 7. It comes with 4 improvements, if you will. So the first one and the most prominent is extremely high throughput. So in the top left there, we get a 5x increase in throughput over 6 or 6E. And that comes with really 3 things. So 4K QAM. So 4K QAM, a QAM is basically how much data per radio wave you can send. And so it doesn't exactly translate into like 4,000 bits or anything like that. It's the previous generation was 1K QAM. We got a 4K QAM. So it's about a 20% increase in throughput, all things being equal. So if your channel widths are the same and your transmit power is the same, then you're going to get about a 20% increase just by going to 4K QAM. We also get 16 spatial streams. So 16 spatial streams is double what we had in the past. We had 8 spatial streams, we go to 16. And so the spatial streams basically is how many devices can talk to that AP concurrently, right? So your phone might be a 2x2 device. So it's taking 2 of those spatial streams. So you could have 8 phones talking to that AP if it was 16 spatial streams on that channel concurrently at the same time. And the more spatial streams you have, the more throughput you have, obviously, per device. We also, for the first time, get 320 megahertz wide channels. So previous generation was 160 megahertz wide. And so the width of your channels is basically the amount of data you can send from one device to the access point, or from the access point to that device at any given time. So like lanes on a freeway, right? So massively wide channels. So we'll talk about the performance in a second, but that is the main thing is extremely high throughput. On the top right, we get something called punctured transmission. So in the past, if you're running, say you're running 80 megahertz channels, right? So 80 megahertz channels, really 4 20 megahertz channels combined together. If you had interference on part of that channel, so there was a rogue access point or something causing Wi-Fi interference on part of that channel, you couldn't go around that. You'd have to either waste most of that channel or move the whole channel to some other part of the spectrum and waste that entire piece of spectrum. And so with punctured transmission, we can puncture around interference. So we can allow for interference or rogue APs or something in the middle of an operating channel and puncture around it and utilize that full spectrum. So better channel availability, better throughput, lower latency. This is really the main pieces. Bottom left, we get multi-link operation, which is actually a really exciting thing, is that, in your laptop, in your phone, in your devices, you have a 2.4 radio, you have a 5 radio, you may have a 6 gigahertz radio, but you could only use one of those, right? So your device was going to choose, I'm going to connect to this AP at 5 on the 5 gigahertz channel, and I'm going to stay there. And so with multi-link operation, we can actually do one of 3 things. So we can do link aggregation. So we can, let's say from your phone to the access point, we can connect to the 5 gigahertz channel and the 6 gigahertz channel, send the same data down both channels. So if you get interference on one of those 2 channels, you have backup frames from the other one, and it just fills that in and continues on. So it doesn't have to resend. And so that, does substantially better for latency and throughput. Or we could do link aggregation. You're probably all familiar with this from switches and servers, where you can aggregate multiple links together. So in this case, multiple radios. So you can link aggregate your 5 radio and your 6 radio, or your 2.4 radio and your 6 radio, or however you want to do it to increase your throughput. Or you can do link selection, which means, let's say your high priority traffic, your voice traffic, you can send down the 5 gigahertz radio, and you're watching YouTube and email and stuff can go down a low priority, like a 2.4 radio. So you can do quality of service over those radios. So all of those are available to you with multi-link operation. So, you've got the radios in your device, you might as well utilize them. And then lastly, enhanced quality of service. So this one is kind of interesting, where in Wi-Fi, we've been able to do QoS for a long time. So let's say your laptop is talking to an AP, your laptop can prioritize and say, my voice traffic is the most important, and then video traffic is next important, and then my web browsing is the least important. So I can decide what I'm going to send first and then next, and etc. But what you could not do up until now on Wi-Fi is, just because you think that your voice traffic is really important, you still have to wait for everybody else on that channel. Only one person can talk on that channel in Wi-Fi at a time, right? Everyone else has to wait until they're done, then they can take their turn. With with enhanced quality of service, is you can preempt. So you can say, hey, I have something really important. I have voice traffic that has to get out right now. So you can preempt other people's traffic if your quality of service is higher. So that's the first time you've actually been able to control the air and who can speak first, because they have higher priority traffic. So these four pieces make up Wi-Fi 7, the Wi-Fi 7 standard. Now, not all vendors implement all of those pieces, and they may implement them slightly differently, but those are the pieces that are in the standard. So talking about channels, so one of the big things that happened in 6E, but really gets solidified in Wi-Fi 7, is 6 gigahertz, right? And so in the 6 gigahertz spectrum, the FCC gave us in the US 1,200 megahertz of new spectrum. And so to put that in perspective, that's far, far more spectrum than the existing 5 gigahertz and 2.4 combined. So if you look at the graph in the bottom right corner there, you see the number of non-overlapping channels, right? So in 2.4 gigahertz, we get 3 channels maximum non-overlapping, right? 1, 6, and 11. That's all we're ever going to get in 2.4. 5 gigahertz, at 20 megahertz channels, you get 25, so that's pretty good. But most people run 80 megahertz wide channels, so you've got 6 available channels. So that means you can have 6 APs that can see each other without co-channel interference. So in a small business, a small carpeted enterprise, that's sufficient in most cases. However, if you're in a hotel, you're in a stadium, you're in a convention center, you're in a warehouse, you're in anything where multiple APs can see each other, that's not enough. And so what 6 gigahertz gives us is 14 channels, 14 additional channels at 80 megahertz. But if you're running, say, a stadium that has 200 APs that can all see each other, you take the 25 out of 5 gigahertz at 20 megahertz, and then add another 59, all of a sudden you have a very workable solution. The other thing, and it doesn't even show it on here, is we didn't have 320 megahertz channels, right? We had a maximum of 260 megahertz channels, but in most cases you only have 1. And it adds another 760 megahertz channels, and 320 megahertz, there's going to be 1 at 5 gigahertz, but you're going to get 3 320 megahertz channels, which is a massively wide channel. So many additional channels. And I mean, airtime is king, right? Clean airtime is the most important factor you can have in Wi-Fi. And so, any additional channels you can get is great. And the wider those channels are, the faster your clients can talk to the network. So just to put that in perspective, right? So in Wi-Fi 4, or 802.11n, we had 600 megabits was the absolute maximum theoretical speed you could get with the maximum number of spatial streams. But your average device, your average phone was about 300 megabits. Now, the reality is that is the theoretical maximum. The actual throughput you're going to get from a real device is about half that. So about 150 megabit is typical. We went to 802.11ac, we got a big boost, right? So, you went to theoretically almost 7 gigs. A typical device 1.7. So, you know, you're going to get half that would be, so you're still under a gig. Then we went to 6 and 6E. So 9.6 gig was the theoretical maximum. 2.5 gig was, you know, a typical device. So a little over a gig was about the best you could do. Then we go to Wi-Fi 7. Look at the theoretical maximum, 46.4 gigabits per second per AP, right? I mean, it is an absolute crazy number. Now, you're probably not going to hit that in real life because you're not going to be running 320 megahertz wide channels. You're not going to be running 16 spatial streams probably, but that is, you know, the theoretical maximum is just a wildly massive number. But even if you look at the 2 spatial streams, you know, you're at 5.8. So you've got, you know, almost 3 gigs, typical. It's wildly huge numbers. So really there's 3 things that the kind of the latest generation. So there's AR and VR, right? Requires extremely low latency. It does require speed, but latency is a big thing, right? If you are doing a real-time conversation or you're doing real-time augmented reality, you're walking down the street with a headset on, your latency has to be close to 0, right? If you've got latency for you to you know, jitter your way over and see that person, that ruins the whole reality of it, right? So low latency is extremely important. And with all the speed of Wi-Fi 7, you also get amazingly low latency. So we also get high reliability that we talked about, and high speed. So high reliability with, you know, with being able to combine channels together, et cetera. Video conferencing, like we're doing today, right? There's massive amounts of video conferencing. Almost all of that is done over Wi-Fi. We have social gaming and esports. Anyone that has kids will tell you if you have latency or your performance is bad during online gaming and esports, you've got a problem, right? And so, you know, it is massively important to have low latency and high performance. We also get 8K streaming, right? So 8K video screens, very common. As streaming becomes more common in 8K, again, high performance, low latency, all requirements. And then IoT and operational technology. So this is a big one. So if you have automated forklifts in a warehouse, for example, you have to have reliability and you have to have low latency, right? If somebody steps out in front of that forklift and it takes a second for that thing to register that there's somebody in front of it and it runs them down, you've got a problem and probably a lawsuit. So again, low latency, very, very important, and reliability. So where we're seeing Wi-Fi 7 adopted early is, we talked about manufacturing, warehousing, hospitality, where you've got lots of access points. Each room has an access point. And so you need more channels, more bandwidth, more availability. Education, again, schools, lots of APs, right? That can see each other, more channels, more devices on board. And then lastly, large public venues. So a stadium may have 200, 250, 300 access points. Any additional channels you can get and the more users you can get, the better the user satisfaction is. So that's where we see it first. Obviously, it's in enterprise, it's everywhere, but those are the ones that kind of are the early adopters because they need it more than us. So let's talk about, we did a little testing, right? Because, you know, we bring up these standards and we go, hey, did it really get better, right? Is it's a lot of words on a data sheet, but did it really improve anything? So we tested multi-link operation in our lab, right? But in this example, you can see we sent basically the same amount of traffic on the 5 gigahertz radio, on the 6 gigahertz radio from a client to an access point, and vice versa. So uplink and downlink. So they start off fine, and then we introduce interference in that graph. So you can see the interference starts, and the interference was in the 6 gigahertz radio. So you can see that the throughput of the 6 gigahertz radio drops way down slack, right? So it picks up its performance to fill in all the holes that were left by the interference. And so both uplink and downlink improved substantially, right? And so we really didn't lose any throughput during that testing. It's actually pretty cool. And here's another example, right? So again, there's interference on on the radios. We introduce MLO, and you get pretty much perfect performance, right? So your throughput, instead of being all over the place, from 400-ish megabits all the way down to 80 or less, with MLO, it was consistent all the way across. So you get consistency, reliability, about a 40% gain with multi-link operation. And just out of interest, I mean, if you're picking a Wi-Fi 7 access point, not all vendors support MLO. So that's a question that you may want to ask your vendor. So let's talk about AI, right? So you can't have a discussion today without talking about AI, but really, and this doesn't just pertain to Wi-Fi 7, it pertains to all of our Wi-Fi. But how does AI, help you in your network? So, the truth is that none of us are getting more IT budget for staff, right? So most IT departments are understaffed. Folks have taken on far more than they ever have in the past, right? So a single person or a single group may be responsible for server, storage, network, cloud, security, phones, laptops, help desk, pretty much you name it, right? So in a lot of cases, we spend all of our time just firefighting ongoing issues rather than strategic planning, right? So we spend our time troubleshooting, tracking down issues, poring over logs instead of building and managing a better infrastructure that's going to be more reliable. So, AI really allows us to get back to being strategic because it's always proactively monitoring and managing your environment. So, AI can automate repetitive human tasks without introducing human error. If you have to configure 30 switches, the chance of human error in there is substantial. But AI can do that, consistently and perfectly every time. It can understand your business policies and build a network for you, right? So a hotel is a very different network than a warehouse or a stadium or a hospital, right? And can operate with different parameters. And it can also auto-tune your network based on usage patterns and traffic and RF, right? So it's always monitoring, and it can tune far beyond any person ever could, right? Even if you had a full-time person watching the performance of your environment and trying to tune, they could never get the accuracy and the detail that AI can introduce. We also get advanced troubleshooting. It looks for anomalies, right? It can identify and perform a root cause analysis and recommended actions before anyone's even aware of a problem, right? So there's no more poring over logs or trying to recreate an intermittent issue while your clients are unable to do their job, right? AI has already found a solution before that client's even aware in most cases. So design and optimization, another key piece, right? The system can optimize and redesign based on actual historical and real-time statistics, right? So things like channel planning can be done far better by AI than any human ever could. We'll talk more about that in a minute. So, really it comes down to, what if you come into the office and any issues that the network's having are identified, classified, root caused, and an action plan is ready for your approval? That's what AI does for your environment. So a few specific things about Ruckus AI, and it does say Wi-Fi 7, but it applies to Wi-Fi 6, Wi-Fi 5, etc. So we'll just talk about a few of the awesome things that our AI can do. So, right. So as I said, it's constantly monitoring your network. it's looking for anomalies and trends, right? So not necessarily just one device that can't get on the network, although it will record that, but it's looking for trends of things happening. So when it finds an issue, the system automatically builds an incident. It sets a priority level of that incident based on the scope of the issue. So, is it affecting one user? Is it affecting 50% of the users? Is it affecting one access point or an entire building? So all of those things go into building the scope. It prioritizes priority 1 to 4. So priority 1 is like a network down. Priority 2 is severe network degradation. Priority 3 is it's a problem, but it's not an emergency. And then number 4 is kind of a get to it when you can, but it's still an issue. And then it's going to provide you a root cause. So here's the root cause of this issue, and then here's the recommended action plan to take, right? So all of that is done for you without any user intervention. That is completely automated. So, and in most cases, you're going to get an alert, or you're going to get alerted to an issue long before your users start to call your help desk, right? And just because users aren't calling your help desk and opening a ticket doesn't mean there isn't a problem. It just means they may have given up waiting for their problem to get resolved, or they just, so this is especially true with intermittent issues, right? So once a week, somebody can't print to their printer. Well, that is something that's very, very, very difficult to troubleshoot unless you have statistics and something watching that network. So, one of the great things about AI is it stores that data for a long period of time, right? Months or a year. So you can drill down to what happened, right down to an individual user, days ago, weeks ago, months ago. So if you're troubleshooting an intermittent issue, you can go back and look at exactly what happened to that user, right? Somebody calls your help desk and says, I couldn't get my iPad on the network 2 weeks ago. What was the problem? Well, without AI, you don't know, right? Now you can go back and look at that user and see exactly what happened. Did they have the wrong passphrase? Did they have a terrible signal to noise ratio? Was the DHCP server not giving out IP addresses? You can get all that information, as you need it. So we can also do things like track config changes. So, let's say you want to make a configuration change on your Wi-Fi. You're like, look, let's turn on band balancing, or we'll turn on DFS channels, or, we'll enable some feature. You really don't know, did it improve or did it get worse? I mean, you can assume it got better, but the beauty of AI is that we can actually track those config changes and give you multiple parameters to say whether your network improved or got worse after a config change, or maybe it didn't change at all. And then you can roll back those changes if it got worse, or know that you made the right decision if it improved. AI will also give you recommendations, right? So sometimes it's difficult to know. There's many knobs and widgets within a network, right? And so it's difficult to understand if those will improve your environment and exactly how they work in many cases. So AI will monitor your network with real statistics and give you a recommendation, right? So it'll say, hey, you should turn on DFS channels because you have, you don't have enough available channels, and it will give you a information on why it's making that recommendation, and then potential trade-offs if you apply it, right? So it'll say, here's why you should do this, and here's potentially the downside if there is any. And then lastly that I wanted to point out, and AI does much more than this, but these are just a few of the interesting things. Maybe my favorite is Cloud RRM, or Radio Resource Management. And so, you've only got so many available channels. We talked about that before, right? So on 5 gigahertz, you've got, let's say, 6 available channels, depending on the channel width you're running, of course. So it's really, really difficult to build a perfect RF environment Some people try to manually set their APs to certain channels. There is algorithms that basically listen to all the surrounding APs and rogue APs and try to decide what the best channel is for that AP. But and clean airtime is king, right? You want no channel overlap if at all possible. So what Cloud RRM does for the first time is we have enough power, enough horsepower, and a big enough algorithm to know every single access point that's in your environment, what channel they're on, what their channel width is, what their output power is. And so that algorithm will build or attempt to build a perfect RF environment, right? So not only does it change channels, but it can increase or decrease channel width, and it can increase or decrease an AP's output power to try to build a perfect RF environment. And so it does that with 7 days of data, right? So it's not like somebody drove by with an SSID broadcasting in their car and we're going to change all the channels. It uses statistical data over multiple days, and then once you enable it, it reruns that algorithm every 24 hours and says, is this network still as perfect as it can be? And then 24 hours later, it reruns it. Is it still perfect? And so it will try to not just build you a perfect RF environment, but also maintain that perfect environment, day in and day out. So absolutely amazing, and something you may think you can build a better channel plan yourself and outthink AI, but I assure you cannot. It is actually pretty stunning. So what do you need to do to get ready for Wi-Fi 7? So there's a couple of pieces you really need to think about in this generation. So one is your cabling, right? So you're going to need 2.5 gigabits, 5 gigabit, 10 gigabits to your AP. So if you're still running Cat5 cable, you're probably going to want to upgrade that to Cat6X. So cabling is one thing you're going to want to think about for sure. Next is your switching environment. So as I said, 2.5 gig is kind of the minimum. Even though an AP will run at 1 gig, you're going to lose all the benefits of that extra horsepower, right? So 2.5 gig is kind of the minimum on your switch ports. You're probably going to want to go to 5 or 10 gig. And so even if you're choosing APs today that don't need it, the fact is, in most cases, switches probably have twice the lifespan of APs in terms of useful life, because Wi-Fi changes every 3 years, 4 years, we get a new Wi-Fi standard. And so you're probably going to be swapping out your Wi-Fi in 4 years, 5 years, where switches often live 8 years or even more, 10 years sometimes. So you're going to want to choose the right switches, from the get-go. The other thing, the amount of PoE power. So if the switches you're running today are 15.4 watts or even 30 watts, you may want to be thinking about going to 802.3 BT or 60 watt power, maybe 90 watt power for the future. So, we've added an additional radio, right? So we don't just have the 2.4 and the 5 radios. We now have a 6 gigabit radio. And so that all requires more PoE power to power.
Hey,
and
Terry,
then lastly,
what are your thoughts on, in terms of preparing for Wi-Fi 7? What are your thoughts on people doing active spectrum analysis or an active Wi-Fi assessment versus a passive or predictive to really get this dialed in? What do you think about that?
That's a great question. And yeah, it's certainly 6 gigahertz is a smaller wavelength. So you definitely want to plan. And so anytime you can do an active is ideal, right? I mean, we can do a passive and we can be pretty good, but if you want maximum coverage and maximum performance, you're going to want to do an active, no doubt. So, and in 6 gigahertz spectrum, we actually have low indoor power mode, which is what most people would run today, which turns the radios down 6 dB or so. So it's actually a substantially smaller coverage area than 5 gigahertz than you're used to today. Or you can run standard power mode. And in order to run standard power mode, your APs have to be certified by the FCC, and you have to basically register them. So the AP has to send its GPS coordinates every 24 hours in order to stay in standard power mode. And even in standard power mode, you still have a smaller signal than 5. So yeah, anytime you can do an active, it's absolutely, highly recommended for sure. Yeah. Okay, so the last piece I was going to talk about, and it's not a hardware piece per se, but 6 gigahertz requires WPA3 security. So most networks, probably 99% of the networks out there today, run WPA2. It's been around for a very long time. However, there was a security hole in WPA2, so we went to WPA3, and it is a requirement for 6 gigahertz. So you cannot run a 6 gigahertz network without WPA3. And so, most client devices made in the last, let's say, 5 years support WPA3. It's not really a big deal, but it's something you need to think about. So do you need to convert your existing SSIDs to WPA3? Do you need to plan for different client devices? Maybe you've got old hand scanners or something out there that don't do WPA3. It's just something to think about. So for the most part, if any device that supports 6 gigahertz is going to support WPA3, so not usually an issue from that perspective. But if you want to, have devices that can cross 2.4 to 5 to 6, WPA3 is the only way to do that, or a mixed mode. But something to think about anyway. And then, from our perspective, Wi-Fi 7 is just the tip of our product iceberg. I'm not going to go through our products. That's not what this is for. But, we do have a full line of indoor and outdoor access points. We have a full line of switches from a 8-port compact up to many ports of 40 gig or 100 gig Ethernet. We have CloudPath, which is CloudPath is our secure onboarding solution. So if you want to onboard users with a certificate, for example, and have a certificate authority, we can do that. You can do policy-based onboarding. So if it's a BYOD, then you can apply a different policy to those clients than corporate-owned clients. Or if it's a teacher versus a student, or you could build policies and what people have access to based on their device type and what type of a user they are. It'll do dynamic pre-shared key. So, if you're doing, say, an apartment building, every apartment, so all the apartments can connect to the same SSID, but each apartment has a different key. So their key allows them to see all the devices in their apartment, but they can't see their neighbors and vice versa. But you can take your laptop down to the pool and connect to devices in your apartment as though you're sitting there, right? So that's another piece that CloudPath would handle very well. We have Ruckus One, which is Ruckus Cloud, and it's called Ruckus One because its goal in life is to combine all of those. So wireless management, switch management, analytics, CloudPath, soon the IoT server, all of those pieces into one pane of glass, be able to manage everything from one place. And then we do have an IoT server as well. So almost all of our APs have BLE and Zigbee radios. And so you might be doing BLE door locks or window shades or something like that. So we can backhaul all of that IoT into our server and either hand it off to the manufacturer, so like your door lock server, for example, or we have an if then else engine. So if somebody unlocks this hotel room door, then open the shades and turn on the TV and turn on the lights, kind of thing, right? And set the temperature to 72. So there's multiple pieces that make up our solution. We don't just offer access points and switches. So be happy to talk to you about that. And of course, we're owned by CommScope, so any sort of cabling needs is there as well. So just to toot our horn for a second, we got the Innovation of the Year award from the Wi-Fi Award. So our Wi-Fi 7 R770 won the Innovation of the Year award against all the other vendors. So that was pretty cool. And then lastly, every client device that gets certified for Wi-Fi 7, not just client device, but APs and everything, anything that has Wi-Fi 7 certified has to go through the Wi-Fi Alliance, right? So they're the ones that certify it. And Ruckus is the test bed for the Wi-Fi Alliance. So every single client that gets Wi-Fi 7 certified gets certified against a Ruckus access point. So if you're buying Wi-Fi 7 client, and then lastly, AFC automated frequency coordination. So that's what makes the standard power work in 6 gigahertz, right? So your AP has to send its GPS coordinates to the SCC database, and it will say you can use these channels and this power level. And so every single Wi-Fi 6E or 7 AP out has to be AFC certified. And so we are, as of now, Wi-Fi or AP on the market, right? The only certified one for AFC. So, all right, that's it. A lot of things in there apply to multiple vendors, certainly all of the Wi-Fi 7 standards, but, for sure, make sure that the products you're buying have the features that you need. Okay, anybody want to ask anything before we wrap up?
No, it doesn't look like we've had any questions so far. We'll give everybody just a minute to see if anybody wants to throw their hand up, to throw a question in there, or have anything specific they want to ask Terry with all his broad knowledge. We'll give everybody just a second.
Well, it looks like I did a great job. Doesn't seem to be any questions coming in.
So we appreciate everybody for joining us. And Terry, again, thank you for coming in and presenting this for us. And we look forward to seeing everybody next time.
Thanks all.
Bye-bye.